Hi everyone, in this video we are going to deal with this type of functions, how to find the derivatives from the first principle. These are the special cases. We can see that x cube, then 1 over x, then square root of x, then constant function. Okay, we can start with the x cube. F of x is equal to x cube. Just find f of x plus h. So is equal to this side, what happened, x become x plus h whole cube. So that we can write it in three separate brackets, that is x plus h, then x plus h. Because of the power 3, we can write the base 3 times, you know that one. Now use FOIL method or straight method to find multiply the first two brackets. So it's going to be x square plus 2xh plus h square, you know that one. Then that bracket is going to multiply the third binomial, that is x plus h, that is this one I am talking. Again, take each term from the first bracket, multiply each term of the second bracket, that is take x square and multiply, that is going to be x cube, then x square h. Same do it to the next term of the first bracket, that is 2xh is going to multiply each term of the second bracket. So it's going to be 2x square h plus 2xh square, you get it. Now one more term left there in the first bracket, that is h square, do the same thing. So it's going to be h square x plus h cube, you get it. So this is, we can simplify it, that is x cube plus x square h and 2x square h, like terms is going to be 3x square h, then xh square and xh square, they are again like terms, that is 3xh square, then last one is h cube. So this is the final product of f of x plus h. Now we can use the formula, that is f dash x limit h tends to 0, f of x plus h minus f of x divided by h. Now you have to substitute, which is equal to limit h tends to 0. In the place of f of x plus h, we can write the long one, that is x cube plus 3x square h plus 3xh square plus h cube. Then the formula, what is minus is there, then f of x is a single term, that is x cube divided by h. Only one number is there, x cube, and minus x cube will be cancelled. Then take the h outside, that is limit h tends to 0. Whatever is left there in the numerator, h is the common. Take h outside, that is 3x square plus 3xh plus h square will be there when you take h outside from the numerator inside the bracket. Then h in the denominator, we can cancel it. Now we can apply limit, so it's going to be 3x square plus 3x times 0 plus 0 square. So it's going to be 3x square is the answer. It's clear? Now we can move to the next question, that is f of x. F of x is equal to 1 over x. See, a fraction, how do we do it? Just the one that you know, go ahead. That is f of x plus h is equal to 1 over x plus h. Now we can write the formula, f dash x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Every time I am writing the formula because you must know it is very important. Limit h tends to 0, substitute f of x plus h is 1 over x plus h minus f of x is 1 over x divided by h. Now look at the numerator, this one we can simplify. What is the denominator here? X plus h, here x. So what is the LCM? LCM is just to multiply both, that is x plus h times x is the LCM, right? Now I am simplifying, that is a limit h tends to 0, 1 over x plus h has to multiply with the x, then only LCM number you get it. So numerator also x, you know this one, 1 over x, the next term you have to multiply with what to get the LCM? multiply with the x plus h. So here also x plus h bracket, all divided by h. See, the LCM, how fractions are there, you have to find the LCM. Even if it is algebraic expression, you have to do the same. Algebraic fractions, you have to do the same thing. So it's going to be limit h tends to 0. Numerator will get x in the over x times x plus h, right? The second term is minus x plus h bracket divided by x times x plus h. The LCM process, you know that, divided by h. Now I am simplifying the numerator because the denominators are same. I am writing that LCM, limit h tends to 0. What is the denominator? LCM x times x plus h. Up you will get x minus bracket x plus h, right? Then divided by h, I am just writing like this, divided by h, bottom one. Now I am simplifying, so it's going to be limit h tends to 0, opening the bracket, x minus h divided by, I can, even if you leave it, the denominator, this one as it is, or you can open bracket, nothing wrong, x square plus xh. Division sign, I am changing it to multiplication, or 1 over h. You know that one, h over 1 going to be 1 over h. That is limit h tends to 0. This cancel, minus h will be there, over x square plus xh times 1 over h. Now we can cancel this 2. So it's going to be limit h tends to 0 minus 1 over x square plus xh. Now we can apply the limit, there is no problem, undefined condition, only this term becomes 0, right? X square will be there after applying the limit. So there will not be any undefined condition. So the answer is minus 1 over x square plus x times 0, so which is going to be minus 1 over x square is the answer, right? Okay, third question is f of x is equal to square root of x. You have to find f of x plus h. Replace x in f of x with the x plus h. Square root of x plus h. Now I cannot simplify more in f of x plus h. I can take both of them to the formula. So let me write the formula. F dash x is limit h tends to 0, f of x plus h minus f of x divided by h. Now I am going to substitute both f of x plus h and f of x in the formula. That is limit h tends to 0. So I am going to write square root of x plus h minus f of x. I am going to write square root of x divided by h. Now what am I going to do? Here the technique that I am going to use is rationalizing the numerator. That is the only way we can move on here. Rationalizing the numerator. That is, I will show you here. Just write limit h tends to 0, square root of x plus h minus square root of x divided by h. So this numerator is going to multiply with the square root of x plus h plus square root of x. You cannot multiply numerator alone with this one. You have to multiply with the denominator also. So square root of x plus h plus square root of x. So numerator and denominator with the square root of x plus h plus square root of x. Now we can simplify this very easily. In fact, I know in the beginning I told you these are the special cases when it comes to square root of x. When you differentiate from first principle, this is how we are doing. So the numerator, it was square root of x plus h minus square root of x. You have to multiply numerator and denominator with the square root of x plus h plus square root of x. I will show you why I multiplied with this. See, now it's going to be limit h tends to 0, Look at the numerator. If I name this one is A, this one is B. See the very same A here, B. So it's going to be A minus B, A plus B. You can see that one. You already know that A minus B, A plus B. When you multiply these two binomial, what will be the answer? This result, you know that one. As this rule, A square minus B square. That is the difference of two perfect squares. We can write it in two brackets, one with the negative, other one with the negative sign, other one with the positive sign. You know that one. So the very same thing, I'm going to use it here. Here A is square root of x plus h and b is square root of x. So A minus B, then A plus B. It is going to be what? A square minus B square. Since A is square root of x plus h, A square is square root of x plus h whole square minus square B is square root of x. So B square is, see, I can reduce that one. I can reduce that numerator like this. That is, numerator was in the form of A minus B, A plus B. So this is equal to A square minus B square divided by, I'm just writing the denominator as it is. That is h times square root of x plus h plus square root of x. It's clear. Now it is going to be, you can see that it is equal to limit h tends to 0. When you square a square root, what will happen? Square root will be gone. It will disappear. So what do you get? The numerator x plus h minus, same, squaring a square root will be vanished, so you will get x divided by h bracket square root of x plus h plus square root of x. You will get it. So the main technique that I used here is I rationalized the numerator. Okay, that is the main method that I applied here. Now it is going to be limit h tends to 0. What will happen? This x minus x gone. What will you get? H will be there in the numerator and denominator also h. Then inside the bracket square root of x plus h plus square root of x. See, then h also cancel. Then limit h tends to 0. 1 divided by square root of x plus h plus square root of x. Now we can apply limit. There you won't get an undefined condition. So it's going to be 1 over square root of x plus 0 plus square root of x. So that is 1 over square root of x plus square root of x. It is equal to 1 over 2 square root of x. That is going to be our answer, f dash x. It's going to be 1 over 2 times square root of x. Is it clear? Okay, question number 4. F of x is equal to a constant function, because there is no variable there to differentiate. So such a situation, what you get? Okay, here answer I will tell you in advance. Here when you differentiate a constant function, always it is going to be 0. I will show you with the help of first principle. It's very simple. Let's see here. F of x plus h. Again you get the constant a again. Why? Because there is no x to replace with the x plus h. Now you can use the formula f dash x limit h tends to 0, f of x plus h minus f of x divided by h. Now I am going to substitute f of x plus h and f of x. That is limit h tends to 0. F of x plus h is a minus f of x also again a divided by h. Now you can see that it's going to be 0. Limit h tends to 0 is going to be, numerator is 0 and denominator is h. That is limit h tends to 0. The whole thing is going to be 0, right? So the limit is invalid, so we can just write the answer 0. So here the important thing is, what you understand from here is, when you differentiate a constant, a number without a variable to be differentiated, you always get what? A 0. Now, instead of using first principle to differentiate or to find derivatives, we can use rules that help us to differentiate, which is pretty easier than first principle. In my next video, we will discuss about the rules for differentiation. So see you in my next video. Until then, bye bye.